Hello everyone and welcome to another YouTube video from Programming 2. This week we're going to be talking about the Java Collections framework in class, and this video is just going to cover one type of collection that you'll be using quite frequently called an array list. So we'll go ahead and get started and instantiate a new array list. We'll just call it list is equal to new array list like that. And that is from the java.util.ArrayList package. Now, what we usually want to do is we want to specify the type of objects that we're storing in our array list. And classes in the Java collection framework are parameterized. So we're going to introduce some notation here. So the angular brackets and then the integer specifies that this array list stores integer objects. So these aren't primitive integers that you're used to, like these sorts. They're in fact full objects, and they store an integer. And they're quite useful for the collections that we're going to be talking about this week in class. So here's how we create a new list of integers. And what can we do with that? Well, we can add some integers like so. And we'll run this in a second. Let's just see what we get. So let's just debug some of this. So here you can notice right at the top I have a list, and I populate it step by step using this add operation here, and it adds the 5. Adds 1, adds 3, -1, and 0, etc. Of course, we can also remove elements, list.remove, and we can tell it which element to remove, the index of the element, such as if remove the first element in the list, or we can also say list.remove another object, the third object in the list. So let's see how that it affects the array list. So looking up here at the top, you can see the array list, and as it the code executes, it increases the number of elements in the list. So here we're going to remove the element 5. That's the first element in the list, and we add another 3. We add -1, and we can remove third. Of course, right away, if we remove something that is too far out of the array list, then we get an index out of bounds exception, and we're used to these sorts of things. We might have that might have happened to us using primitive arrays. So we have an array list of size 3, but we try to access the third index. So of course, the indices only go up to 2, and therefore we have an exception. So as with any collection in this framework, we're going to have to be careful that we actually access the correct bounds of the array. So perhaps we should have put 2 instead of 3, and if we rerun that, we can see that it then, here we go, remove the second one, so that removes -1, and we can also add another one. To add a 0, we add another element. So one of the interesting things that we can do with these array lists is that we can sort them. And there are, in the collections class, we can then just type in sort, and given the list, just sort it. So let's go ahead and input a list here. We have to import that as well, of course, because it's a class and it stores many static methods for operating over array lists and other collections. So just like this, going through. Now, watching this is not in correctly sorted order, and if we just click that and go sorting the collection, we immediately sort the collection, and that's the end of the program. So that's a very useful thing to have. But what else can we do? Well, we can also store, for example, customer objects. So imagine that we want to create some class that stored an array list of customers, and here's how you would do that. It's almost identical, really. Here in the array list, I'm now specifying that I'm storing customer objects. So that's what these type parameters do. They specify the type of the object or the class of the object that you're storing. And I'm here using add, and I can just add and remove customers as I would if they were just if my array list was storing numbers. So just stepping through like this, you can see the customers here, and I have the name of the customer and their age, like that. So exactly like the numbers. But the question comes up, how would we sort this? Because when we type something like that, collections.sort, it's still an array list, but all of a sudden we can't sort it now. We can't, we're going to have some problems, and it says the method sort list in the typed collection is not applicable for the arguments array list customers. And what it comes down to is the fact is that we have no way of ordering customers. We have no way in deciding which customers should come first in the list, which should come second, which should come third. With numbers, it's quite easy. There's a natural ordering of these numbers. So for instance, we know in a list, if we're going to sort it numerically, then 1 should appear before 5, and -1 should appear before 0, and then 0, 1, 5, that sort of thing. So the way that we could do this in Java, the way that we could give an ordering, a total order on our customer class, is by implementing an interface. So what we have to do is we have to tell Java the way that we're going to compare these. So given two customers, we could tell which one comes before the other. That's what's called a total ordering. So what we're going to do is we're going to implement a comparable interface, and we're going to give it customer, because it as well is has a parameter type. So we then have to add the unimplemented methods. We're going to talk about this in the first class this week. So if you don't know what an interface is, that's fine. I haven't covered it yet, but it will be covered. So what I had to do then is I had implemented a comparable interface, and now the way that I do that is I then have to define a method body for this particular method, compare to. So given a customer O, I want to compare it to this customer. So if how would I do that then? Well, it's quite easy. So let's go ahead and try that. So let's say I want to compare customers according to their age. So the customer that is older comes later, I suppose, in the array list. So the younger customers that are younger are first. So that's pretty easy to implement. All we need to do is compare ages. So we say this dot compare to, and this input customer O dot age, and this is actually this dot age dot compare to. So now all I'm doing is just comparing numbers, and if I run this example here, I should see that I just initialize the array like that. Okay, and if I sort them, then I have 18 is first, then 25, and then 30, and then 40, because I'm ordering them according to the age. So the youngest customer becomes first, and then the older ones as we go down the line. So that's basically it. What happens if I wanted to order it according to alphabetical order, let's say? Let's say I want to order it so Alice, then Earl, then Frank, then Ken, in that order. That's pretty easy as well. And what we can do is, instead of comparing ages, all we have to do is compare strings. And to compare a string, it's basically alphabetically compared or lexicographically compared. So this dot compared to O dot name. And if we do that, then going back and initializing our array, and we could just run it like that. So here you can see that it's out of order, and whenever we sort it, it becomes in alphabetical order. So Alice, Earl, Frank, and Ken. So there'll be a lot more details in class and in the lab, so look forward to seeing you there. Goodbye.